Here's my presentation, and first I want to start with an introduction. And first, I want to introduce what is Platonism and what is fictionalism. So, Platonism, or specifically mathematical Platonism, refers to the statement that abstract mathematical objects exist and exist outside of space and time. For example, they are non-spatial temporal, and our mathematical sentences describe these objects. So basically, this is one ontological statement and one semantic statement. And for fictionalism, it is a type of anti-Platonism, meaning objection or against Platonism. And semantic-wise, it is similar to Platonism in stating that our mathematical sentences describe mathematical entities, but it denies the existence of mathematical entities. So, for example, the statement that 3 is prime is a false statement for fictionalism because 3 doesn't exist. And then we can introduce what's the Quine-Putnam indispensability argument. If we put it in a syllogism, it basically states that premise A, we must ontologically commit to entities that are indispensable to our best scientific theories. Premise B, mathematical entities are indispensable to our best scientific theories. In conclusion, we must ontologically commit to mathematical entities. Take quantum mechanics as an example. It is one of the best scientific theories we have. So in this case, according to the argument, we need to ontologically commit, or we need to commit the existence of Hilbert space and complex number that are used by quantum mechanics. And there are primarily two types of objection to the argument. Since I put it in a valid way, the two objections would be either objection to premise B or objection to premise A. And objection to premise B is basically proposed by scholars like Hartree-Field. And for example, he is trying to nominalize scientific theories without mathematical entities. But this is sort of a heavy task for a short essay. And for this essay, I will assume that premise B is right and I will challenge premise A, which is we must ontologically commit to indispensable entities. And so then we can first review what exactly is premise A. Premise A, in essence is uh, primarily based on two foundations, naturalism and conformational holism. Naturalism states that science with philosophy as a continuous part can provide a complete picture of the world, while conformational holism states that theories are confirmed or disconfirmed as wholes rather than in separation. So in this case, naturalism puts us to believe or ontologically commit to science only, and conformational holism pushes us to commit to all the sciences. So that's an only and all relationship, which justifies A. And the famous objection to this is proposed by Maddie about the scientific practice objection, which states that conformational holism is untenable because scientists in practice do not treat all components of a well-confirmed theory with equal epistemic confidence. So, for example, despite the empirical success of atomic theory in the late 19th century, many physicists remain skeptical about the existence of atoms until Einstein's 1905 work on Brownian motion. And a probable Platonist objection towards this is that mathematical components of theories always fall within true elements rather than merely useful elements. However, this can be easily countered by any or pretty much most of the scientific practices, which shows that mathematics are more of an instrumental tool. For example, when we model water, in water wave series, we usually model it as infinitely deep. And then we can step into my first objection, which is also against conformational holism. What I do here is basically dissect Maddie's argument and see what's the essential problem of conformational holism. So first, this argument heavily relies on indispensability of science, but what are the aspects and the nature of science exactly? First, science is not completely objective, and we do not judge science only on the basis of accuracy in describing the world. There are also other factors that we need to take into consideration. For example, aesthetics. We have Occam's razor, which basically is aesthetics of simplicity, and Einstein's theory of relativity creativity is like accepted even before practice simply because it is beautiful. And another example is about those social and cultural background. And for example, the heliocentric model has been proposed, like traced back to like Greek life, but it is accepted very late, like hundreds of years later than that. That is because the shift in social and cultural background leads to the acceptance of scientific theories. So in this case, we can conclude that there are at least two aspects of the nature of science, which is first, science describes the physical world, and second, science carries the characteristics or fulfills the requirements of human. So this creates a contradiction with confirmational holism because confirmational holism is actually treating science as a completely objective or accuracy-based doctrine. This is like a false analogy to soundness. Confirmation in this case, I will say that it is different to soundness because, for example, if a scientist wants to test Ohm's law and he is using the best equipment in the world but still finds some minor error from a linear relationship, in this case, should he object Ohm's law? Well, we know that from our scientific knowledge, we shouldn't object Ohm's law simply because of these errors, because Ohm's law have a very reasonable simplification with reasonable application. There is no such thing as an ohmic conductor, but it can solve real-life problem. So scientific theories are processed by human and not solely accuracy based. Um, for example, factors that are considered include acceptance of assumptions, simplicity, aesthetics. So these humanistic characteristics give science a new standard of confirmation and structure, different from soundness. Soundness basically states that if an argument is sound, then its premise, its conclusion, and the logic chain are all right. But confirmation of scientific theories are different because we do not need all parts to be all right. We only need to have an acceptable or consideration from all aspects, but not all aspects are ontologically accepted. And here we can head on to my second objection, which is the definition of best. This is essentially also the problem of ignoring aspect two of science's nature. And we can first point out that what best does not mean in scientific studies. So best definitely does not mean the most accurate in scientific study. For example, Einstein's relativity is usually considered more accurate than Newtonian physics, but Newtonian physics is still widely used today due to its convenience, for example, in sports analytics and something like that. Because we can use Newtonian physics in a relatively simple way when there is no that much care for errors. Newtonian physics seem to be a better alternative than Einstein's relativity. In this case, we cannot identify the best scientific theory without context. This creates a contradiction with PCI, the principle of causal isolation, which is commonly accepted by Platonists, stating that there are no causal interactions between mathematical and physical objects. This conflict lies in that we might have to ontologically commit to different mathematical entities from one place to another because it depends on context. And this creates some causal relationship between mathematical objects and physical conditions. So we cannot define what's best without context. That's the problem. And third objection is a historical view. And in this objection, I'll point out the third aspect of the nature of science I propose, which is scientific theories are constantly changing. I'll take first an example of luminiferous ether. The luminiferous ether is an assumed medium for transmissions of electromagnetic waves. And physicists at that time usually use elastic solid equations to describe luminiferous ether, and it is commonly used in scientific theories. However, after general relativity is accepted, the theory of luminiferous ether is immediately discarded. In this case, it creates a problem because, as Crane said in the indispensability argument, we should only commit ontologically to mathematical entities that are necessary in our best scientific theories, and other mathematical entities should be treated as mathematical recreation. So in this case, if scientific theories are frequently discarded, then we cannot correctly identify or make sure of the existence of basically any mathematical entity. So this also creates an inconsistency with PCI, which states that there is no such causal relation between human activities or physical entities and mathematical objects. So a probable weak objection towards this is that our core scientific theories are not changing. However, if you look at our atomic theory, we have plum pudding model, we have Schrodinger's model, we have all these, and they proceed in very different manners. And a stronger objection might be mathematical entities remain when scientific theories are changing. A counterargument is that this is basically an overconfidence of our mathematics. We can see a shift from Euclidean geometry to Riemannian geometry as scientific theories shift from Newtonian physics to Einstein's relativity. So another counter is that stability is for pragmatic rather than ontological reasons. So this shows that changes in scientific theories actually lie in pragmatic reasons rather than ontological things. So indispensability in science cannot lead to ontological conclusions. And in this section, after pointing out several objections, I will show that Platonism itself also faces several challenges under indispensability. And first, let's have a conclusion of the previous scientific theories. So scientific theories have at least three characteristics. First, it describes the world. Second, it carries characteristics or needs of humans. And third, it is constantly changing. So a question that Platonists usually ask is, if mathematical entities do not exist at all, why would mathematics function that indispensably for the science that describes the world? But in this case, fictionalists can also question from the perspective of 2 and 3 by saying that if mathematical entities exist abstractly, why would mathematics be so essential to the science that possesses human traits? And why would they be so indispensable for science that frequently changes through time if they are non-spatial temporal? I will use the case of infinity to show why it struggles to explain 2. Why it struggles to explain 3 is already explained in the previous part. And infinity is usually used as an assumption in empirical theories. For example, water as infinitely deep in water wave analysis. The standard model of particles physics assume the size of an electron as infinitely small, and general relativity assumes space as infinitely divisible. So Platonists basically will state what is infinity. It is out of space and time. There exists something infinite, and those non-existent infinities in our scientific theories are imperfect projections of this abstract infinity. But the problem is that we choose to use infinity due to reasons like simplicity rather than because we cannot distinguish their magnitudes from infinity. So why mathematical entities in this case, which are causally isolated from physical entities or even humans, could function indispensably for subjective human choices? So in this case, there is still a gap between pragmatic and ontological conclusions. It is our choice, but not the objective existence of infinity. And now I will step into what fictionalists might take as approaches. There are mainly three approaches. The first one is metaphors. So it is pointed out that mathematical sentences are advanced in a make-believe spirit. What does this mean? So when we say that there are 8 planets in our solar system, we do not intend to refer to the non-spatial temporal object 8. And when we refer to the average woman, for example, in statistics, this average woman also doesn't exist in the world as a real object or entity. In this case, when we are saying these terms, we are expressing it in a figurative way that deviates from the literal meaning or the Platonist so-called objective existence. So in this case, there is a gap between indispensability and existence because we are using mathematical entities in a different way from its literal meaning if it has any. So our usage cannot lead to conclusion of existence. And the second one is structures. Well, for fictionalists, an easy response for infinity can be infinity does not exist but is merely useful. It can explain metaphors in our science as based on pragmatic use. And why is mathematics so useful? it comes structures. Mathematics provides useful structures or frameworks to describe the physical world. And for example, our perception of temperature fits well with the structure of real number continuum. It is not each individual real number itself that is not dispensable because we have Fahrenheit, Celsius, and Kelvin. So the structure of positive integers also, not their existence, is paralleled with the number of planets. So in this case, it is mathematical structures that represent our perception of the world, but not objective existence. And to take a step further, we can say that it's human who created mathematics, or mathematical structures are human conventions. For example, Henry Poincaré has said that we are using the same syllogism infinitely to mathematically induce infinity. So if adding 1 to a number is true for 1, then adding 1 to 2 is getting another number is true for 2, and so on, and it's true for 3, and so on and so forth. So logic cannot prove that this syllogism is still right after being applied infinitely many times because this application of infinite times cannot ever be justified by logic. Logic does not allow infinity, basically. So infinity represents a tendency actually created by our intuition and mind that if it is true in limited scope, then it should be true if we apply it again and again. So in this case, mathematical truths are human or man-made truths, and it is true only when following the rules in its own fiction. For example, Sherlock Holmes is true only in Conan Doyle's novel. And here are my conclusions. First, I point out there are three aspects of the nature of science. First, it describes the physical world, and the problem of Platonism is usually only caring about this but not the others. And second, it carries the characteristics or fulfills the requirement of humans, and this violates the confirmational holism foundation of premise A. And the third one is that scientific theories are constantly changing. This caused instability in the application of the theory. And description of the best of our scientific theories all usually depends on situation. That also causes problem because we cannot make sure of the existence of any mathematical entities. And I also show that Platonism faces the problem of indispensability in explaining too. And I also pointed out several fictionalist responses. For example, we can point to metaphors, we can point to structures, and we can further point to that mathematical entities and structures are human conventions. And that's basically all conclusions on my essay. And some future questions would be why did we reach certain fictions but not others? But this leads to further investigations. And thank you for listening. These are my works cited list.
Thank you. Let me just see if there's any questions from the attendees. No, okay. Maybe if I could ask you, what did you find to be the most challenging part of your research?
Uh, I believe probably the most challenging part is actually choosing the topic because as I'm taking mathematics and philosophy and interdisciplinary approach part the course, and there are many topics that might interest me, and I start up very broad. For example, like uh, considering like different schools of mathematics, but I further narrowed it down by doing many background researches, and I found when I read to this part, the indispensability argument part, I find it really intriguing to me because it appeals to also many other readings I have read. For example, Thomas Kuhn's The Structure of Scientific Revolution, Henry Poincaré's Science and Hypotheses, and basically my challenges more are on choosing the topic. And if for the research process, I believe the topic is more of how to generate my own ideas. But personally, I feel like if I relate to more readings that I have read, some of their conclusions can be a step of my conclusion. For example, Thomas Kuhn has pointed out that science depends on aesthetics, depends on cultural backgrounds, depends on social backgrounds, and I use his conclusion as part of my argument to say that these aspects make confirmational holism not making sense and something like that. Yeah.
Great. Thank you very much for a really thorough and clear and good research project. Thank you for your time today. You may feel free to listen in to the other presentations for the rest of the day, or otherwise have a lovely day. Okay.
Thank you. Bye.